Let us look into this problem now. Based on true and false, the statement is given as for two angles of projection alpha 1 and alpha 2 with same speed, range are same, then alpha 1 plus alpha 2 is not equal to pi by 2. So this is your statement. You have to justify whether this is correct, this is true or false. This angle is alpha 1, this angle is alpha 2. Both the projection velocity is u. The range is same. If the projectile has been thrown from here, it hit the ground over here. This projectile thrown from here and it hit the ground here. So the range is same for both as per question. So you know by definition range is u square means initial velocity square sine 2 alpha 1 by g, and since with alpha 2 also the range is same, so we can write from this so finally you reach to these equations. So for this equation to satisfy it, either this should be 0 or this should be 0 or both should be 0. So let us start with this equals 0. Since alpha 1 and alpha 2 is acute angle, it is not greater than 90 degrees. So therefore, to satisfy this, alpha 1 minus alpha 2 should be 0 and alpha 1 should be equal to alpha 2. But as per question, alpha 1 and alpha 2 are different. Okay, so this will not be our solution. And anyway, we have to check alpha 1 plus alpha 2 if it is not equal to pi by 2. So we will check now this. For this to be 0, alpha 1 plus alpha 2 should be pi by 2, 90 degrees. But in the question, it is saying that alpha 1 plus alpha 2 should not be pi by 2. So it means number 5 statement is false. Now we check for number 6. If a projectile is projected in xy plane as shown in the figure, the equation of trajectory is y is equal to x tan alpha in bracket 1 minus x divided by r. Acceleration is acting downward with g. There is no acceleration in the x direction. Angle of projection is alpha. Initial velocity is u. So you know this y will be, this y coordinate of the projectile means along the y. The position of y can be given at any time as the initial velocity in the vertical direction, that is u sine alpha, the component of this, into p minus because velocity is in this direction, acceleration is acting opposite to it. So this is about y at any time t. The same way we can write the x coordinate of the projectile at any time t, that will be component of velocity in the x direction, and that will remain uniform, will remain same, constant, because no acceleration or no force acting in x direction. So simply multiply it with the t, you will get the x coordinate at any time t for the projectile. So you can write t as x by u cos alpha. If we use this t in this equation, here you can see x tan alpha is a common factor. To make it common from these two terms, what we will do, we will multiply tan alpha and divide by tan alpha. So you take x tan alpha common from both the terms. And tan alpha we can replace with sin alpha by cos alpha. So now in the denominator u square into 2 cos alpha into sin alpha is left over. So we can cos alpha into sin alpha we can replace with sin 2 alpha u square, and g we will bring down. So what is this? U square sin 2 alpha by g is the range. You know this formula. Sorry, here we have taken x, 1x as common. So we will have only 1x in the numerator. Check in. The question number 6 is saying the same thing, it is matching. So this statement, number 6 statement, is true. So we can mark this as true.